Assalamualaikum. In this video, we are going to learn how to calculate the empirical formula from the combustion data. Stay tuned. Let's read the question. The question asks you to determine the empirical formula of isopropyl alcohol. After we read the question, there are few steps that we have to follow in order to solve the problem. The first step is try to identify the element exists. The elements are carbon, hydrogen, and oxygen. The second step is try to identify the information given. We are given the mass of the sample, the mass of the carbon dioxide, and the mass of the water. From the following data, we can tabulate a table to solve the problem. This is an example of table that we can tabulate to solve the problem. The first row represents the element. We have three elements, carbon, hydrogen, and oxygen. The second row is mass, the third row is mole, and the fourth row is the simplest ratio. From the table that we tabulated previously, we found that we need to identify the mass of carbon, hydrogen, and oxygen. But we don't have the information for that. We only have the information for carbon dioxide and water. To identify the mass of carbon, we need to compare with carbon dioxide. While to identify the mass of hydrogen, we need to compare with water. The next calculation step will show you how to compare. First, we need to identify the mass of carbon based on the mass of carbon dioxide given. One thing that you're supposed to know is we only can compare number of mole. We cannot compare mass of the sample. In this case, we need to identify the number of mole carbon dioxide first. The formula to identify the number of mole is equal to mass over molar mass. From there, you can insert the value to identify the number of mole carbon dioxide, which is 0.0128 mole. Once you get the number of mole carbon dioxide, you can write a comparison, which is 1 mole CO2 is equal to 1 mole C, which is carbon. Once you have 0.0128 mole carbon dioxide, meaning that you also have 0.0128 mole carbon. The number of mole carbon that we have is 0.0128 mole. Can you identify the mass of carbon? From the number of mole carbon that we get, we can determine the mass of carbon by using the formula mass is equal to mole times molar mass. In this case, we want to calculate the mass of carbon, so the molar mass is 12. Then you can get the mass of carbon, which is 0.1536 gram. Don't forget to insert the value into a table that you tabulated previously. Now, we will repeat the same procedure to identify the mass of hydrogen. Since we have the mass of water, then we can calculate the number of mole water. From the number of mole water, you can write a comparison, which is 1 mole of water is equal to 2 mole of hydrogen, because we have H2O. If we have 0.017 mole of H2O or water, then you can have the number of mole hydrogen by 2 times 0.017 mole. The number of mole hydrogen is 0.034 mole. And now we can determine the mass of hydrogen by multiply the number of mole hydrogen with the molar mass. The mass of hydrogen is 0.034 gram. Don't forget to insert the value into the table that you tabulate previously. Let's look back at the information that we have. We already determined the mass of carbon and the mass of hydrogen. As I mentioned previously, the mass of carbon can be determined based on carbon dioxide, and the mass of hydrogen can be determined from the mass of water. Now it's time to identify the mass of oxygen exists. If we can see from both carbon dioxide and water, oxygen gas exists in most molecules. Because of that, we cannot compare the number of mole. How to solve the problem? Since we cannot determine the mass of oxygen by comparison with mass of carbon dioxide or water, this is the method used to identify the mass of oxygen. The mass of oxygen can be obtained from mass of sample minus the total mass of carbon and hydrogen. When we insert the value, your mass of oxygen is 0.067 gram. After this, please insert the value into a table that we tabulate previously. And now you can complete your table. You can complete the number of mole carbon and hydrogen. The number of mole carbon and hydrogen is already calculated previously, and calculate the number of mole oxygen. From the number of mole, you can find the simplest ratio. How to get the simplest ratio? Divide the number of mole for each element with the smallest number of mole amongst the element. And finally, you will get the ratio 3, 8 and 0. The empirical formula for isopropyl alcohol are C3H8O.